Dear electronic engineers, are you losing your jobs? Do you have the fear of AI? Do you think that AI will take your jobs? Today, this video is for electronic engineer who stuck in non-core jobs, either in the embedded system, layout engineering, board level engineering, any job. If you're an electronic engineer and if you're in non-core semiconductor jobs, and how you can make this transition from non-core jobs to a core jobs. So in this video, I am going to miss three top strategies any engineer who had made this choice switching from non-core jobs to core jobs where their job is secured in this AI era and they're earning their 2x salary what it compared to before. More than that, it's a passionate about electronics. These people are so passionate about electronics while they are studying, but when they are working, their job is not fulfilling their dreams to become an eminent electronic engineer. So let's get into these three top strategies, and the last point will be an amazing how you can get any job what you want. This strategy which I use and most of my trainees use this strategy. How to switch into semiconductor career if you're an electronic engineer. So either you are in embedded, board level, analog IC design. I am taking an example of embedded engineer. Like if you're an embedded engineer, how you can transition into analog IC design. Today, I am going to discuss top 3 strategies. Most of the engineers have done this before. Do you have this fear? I am already having a 1 to 10 years experience in the different domains in after electronic. And do you think it's too late for me to switch to semiconductor? So always this is the top question. Okay, I have different experience, different skill, and how I can switch now. This is impossible. This is not impossible. So there are two ways how you can switch. Example, you're dominating in one skill and you're working in this job. And how about you combine top 3 skills what you have? Example, your fundamentals and electronics what you have studied, and in that one skill already you are working, and you will learn one more skill which is most required in the industry, and now you combine these top 3 skill which are dominating maybe next 5 to 10 years, combining the existing skills with the skills required in the industry. Strategy number 1, skill bridge method, means how you can bridge your existing skill into the new skills required in the industry. Let's go one by one. First one, map your existing skills to analog IC design. Example, if I'm taking an embedded engineer, how you can map your existing skills to become an analog IC design engineer. You're very good at hardware debugging instinct. How you can convert that hardware debugging into an analog corner debugging, because over the period when you do the debugging you get the debugging knowledge. Second one, how to read the data sheet. How about you utilize the same into device characterization or reading all the data in the analog domain. Third one, microcontroller knowledge, top level knowledge about the system level knowledge, how you can integrate that microcontroller knowledge into a mixed signal interfacing. Second point, I would tell, identify your top 5 hidden transferable skills. Every domain has this transferable skills. Example, signal integrity interference awareness, power management understanding, interrupt handling like our feedback loop intuition, memory mapping, hierarchy which is equal to hierarchy design thinking, real time debugging, simulation debugging. So you can map like, okay, I used to do this one, now I can do this one in the new job. Third point, I would say, use previous experience as your interview advantages. How you can become better than the fresh engineers is many fresh engineer doesn't know what they're doing, how they're doing, what is the expectation in the interview, what is the expectation from the company, because most of the things what usually interviewer ask you, you won't be able to doing the same thing in the company, and as most of the experienced people know. So take frame firmware projects as a system level analog interfaces. If you are working in the embedded the firmware, you just map the present knowledge with the new knowledge or new skill required. Show your understanding in both side of the chip, like in the system level as well as the IC designer. Position as an analog designer who thinks like a system level engineer. So this is a bridging gap. Many of you miss this, how to bridge your present skill to the new skill. The fourth point, bridge the device physics gap in 30 days. Example, whatever the fundamentals you think you don't know, okay, these are things I required in analog, I don't know these things. You can bridge. Example, MOSFET, IV characterization, and all the operating reasons. Like you can quickly study what's happening in this one. Small signal model derivations, saturation, triode, subthreshold, whatever you have studied in your BTech or masters in electronics or electrical or maybe instrumentation. You can build this in maybe 30 to 45 days, revising or fundamentals before going for the bigger step. And the fifth point, like a tool transition. Whatever the tools you are using, the most of the tools are either in the electronics are similar. I'm not telling it's exactly same, but it's mostly similar. Start using like free PDK, Sky 130 PDK, Cadence ADA basics in 1 week, and start simulating. Maybe take simple blocks, inverters, current mirrors, single stage amplifiers. First start simulating instead of you getting into only theoretical mode forever. At least use even open tool like Spectre, open tool LT Spice to simulate and see how you can transfer your theoretical knowledge into practical hands-on. The sixth and important, build the bridge project that combines both the worlds. Example, you might be doing working something on the system level, and how about you design an analog front end for the microcontroller? Example, if you're an embedded engineer working for the microcontroller, right? How about bridge? At least how about you understand, okay, this is what you used to do, this is what I will be end up doing it. I design 2 to 3 industry projects which are related to the new skill what you want to attain. Use this as your portfolio anchor piece. If you don't have the projects, you won't be able to get that hands-on that I have done it and I have the capability to transition from the present skill to the new skill. So to summarize, one is skill bridge method, like strategy one. You use all of these points to map your present skill to the new skill which is required. And if I go to the second point, what is second strategy? So if I use a second strategy, okay, now I don't have the detailed approach how to map whatever I know, but I definitely know what is the expectation in the new job. That is portfolio first approach, means learning exactly what the new skill required, new domain required. Example, the three must have project every hiring manager respects, especially in the analog IC design. Example, two-stage op amp proves all the fundamental integrated, and the reason is op amp is widely used in most of the circuits in analog domain. If you have designed two-stage op amp from scratch in the transistor level, that beats most of your theoretical knowledge to transition into hands-on. Second most, which is Bandgap reference, because I always suggest it proves your device physics mastery, like what is uh, process, voltage, temperature. This understanding is more important in the analog domain. So this, if you design one Bandgap reference, you understand your in-depth device physics. Third one, load dropout regulator. Regulator is more important in the power sector because PMIC or PMU blocks are there in every chips. That's the reason if you understand this low LDO, means you getting the job will be more easier because this vastly required skill maps. Low dropout regulator, because and also it proves your stability and feedback skills. So it means it's exactly hitting the bull's eye if I say what exactly required in the industry. Second one, document each project with hiring manager language. Example, what is the expectation? So what is the difference between what you have done and somebody who is talking theoretical knowledge? That must always make difference. Exactly mention like what are the specification you are targeted, what is accuracy, PSR, dropout voltage, all the stability results. All these results should be documented and this should be reflecting in your resume to stand out from the theoretical engineer to hands-on engineer. Second, mention trade-off encounter, design decisions made. Interviewer want to know the context of your projects, not the content of your project. So always they check, are you capable to do the new project? Third one, simulation evidence like waveforms, corner data, Monte Carlos, right? If you have these things, whenever the interviewer asks you, if you are able to break down your schematics, transistor, voltage, current, device sizing. So this beats you most of the theoretical engineers to hands-on engineers. Third point, use real industry PDKs. So instead of just using whatever is available in the GPDKs, I suggest always I use a PDKs which are available freely, like Sky 130 free or from Google or Skywater partnership. Global Foundries 180 nanometer available via University Access. Avoid generic level 1 MOSFET models, because if you use generic PDKs, GPDKs, you don't get in depth the variations across the process voltage and temperatures. It's like using the ideal cases always, and it doesn't make you a good engineer. Run PVT corners on every project. It's a non-negotiable if you want to prove that, if you want to get something in depth, this is non-negotiable. Example, process corners, like stick to this SS, FF, TT, SF and FS. It stands for slow, slow, fast, fast, typical, typical, slow, fast, fast, slow. So these are the combination of your MOSFET between NMOS, PMOS, and you can take and voltage variation you can take plus or minus 10%, supply variation, temperature you can take minus 42 125 degrees Celsius, which are standard temperature variations also. And the fifth one, like if you want to go a little bit advanced and understand about the MOSFET in depth, the layout your top project and separate the serious candidate. Example, let's assume that you know the design as well as a little bit about the layout and what exactly happened in the post layout, right? Apply common centered layout technique, few layout techniques, post layout, if how to do the extraction and do the post layout. And if you compare between the post layout and the pre layout or schematic, then you see this difference between at least 10 to 15% of variation I'm seeing from the schematic to the layout. So understanding the difference is more important. As a design engineer, I should know from system level how much difference it would make in the schematic, from schematic to layout, from layout to post layout, from post layout result to the silicon result. If I compare between what I assumed in the system level or what I'm seeing at the silicon, the difference, if you can reduce, that makes you a better engineer over the period. The sixth point, and create good resume with the project case studies, not simple again theoretical things. Example, use your own statistics, always statistics in the sense what is the specification you took, numbers if you can mention, and what result you got, what is your assumption. And if you could write all this in the star format: situation, task, action you have taken, and result you got. Always you try to put all your projects and in the star format. It is more easy to explain for you to in the interview, and also it's easy for interview to understand, okay, these guys know in-depth hands-on. And you can put your schematics in the GitHub, make test bench simulations, keep all the things ready if interview want to look into. So this is second strategy to approach based on the portfolio. You build what exactly industry want based on their job description, JD, whichever is available. Then you start building your transition plans. And the third most important thing is how you can transition while you are in the job. Like this is called stealth transition, learning while you are earning. How you can plan this? First, plan while you are employed. Can you transition? If you want to transition your present job, how much time can you spend every day, or what is the minimum time you should spend, and what is the duration it would take if you are planning while you are in the job? Standard time is 90 minutes, like evening protocol. Mornings are a little challenging, but evening protocol, example, let's assume every day you spend this 90 minutes divided in this way. 7:30 to 8 p.m. you will spend on the theory, like textbook or NPTEL videos or Razavi videos from the YouTube. Right? Every day 30 minutes you will spend on learning theoretical things. And with respect to those theoretical things, whatever you learn, you put at least 1 hour from 8 p.m. to 9 p.m. you put on hands-on cadence simulations. So why this is? Because you might have learned this same thing in the theoretical, even in engineering and master, but again you unlearned it. Learning and unlearning is common unless until you implement with your own hands. Until and unless you design with the hand calculation. So that's the reason I always suggest, like in 90 minutes, at least 1 hour you must spend on the, and at least on Saturday, Sunday, you spend at least 4 to 6 hours dedicated deep work for this transition. Okay. And how much this transition would take? How much time it would take? I'll explain in few other points. So negotiate like analog adjacent work. Example, you were in the work. Let's assume, even though if you are closely, example, analog layout engineer, if you are, can you ask for the volunteer simulation work? Maybe post layout simulation work. Second one, take on analog signal condition debugging project. Any debugging project, if you can take which are related to your domain. Right? End of the day, you should get whatever the new domain you're planning. Those skills, interest you should get, and hands-on you should get on that. Real practical application you should get. Third one, partner with hardware team on the analog board. So whichever domain you are, whichever the company you are, if there is a chance that you can do some volunteer extra work after your present work, it's a good way. One of the layout trainee, so you wanted to switch from analog layout to analog IC design engineer, and once he started training program with us, we suggested him that why don't you start doing the post layout simulation for your team. So he started doing this. The designer got a confidence that he can do, and the design manager, he started slowly giving the post layout simulation work, and within 3 to 6 months he could switch from layout engineering to design engineering. Most of the work in the analog, there is simulation work also. As we know, 70% of the time we spend on the verification part. If I know somebody who has done the layout, and they can do better verification because they can debug what is a real issue. And third strategy is build relationship before announcing the switch. Reason is, you should know maximum number of people in the industry who is ready to give you a chance. Example, connect every day 10 analog designers in per month in the LinkedIn. So maybe in by 6 months you have very good connection of your own in the industry who is ready to help you voluntarily, to take mock interview, to teach you something, to train you something, or refer whenever there is openings in their companies. And attend all semiconductor meetups so that you start building the relationship with the hiring managers. Engage thoughtfully on the industry post. Add value, not just like. You start adding value and people will start noticing. So you must start this from the day you decide that you want to switch to analog domain. Why it matters? Because you might be the best engineer, but you might, if you're not showcasing your skills in the industry, and nobody would notice you. Fourth point, time your job switch for maximum leverage. Example, apply only after 3 strong portfolio project complete. The reason I'm telling, you will lose your confidence first. The moment interviewer asks, if you're not able to answer. Second, you might also lose opportunity. Let's assume 5 hiring managers and you sent all the 5 hiring managers without preparing, and you got an opportunity at least for 2 and you could not crack the interview. So you lost the 2 opportunities also. So I suggest attend minimum 3 projects you do, and then you make your resume and then you start applying. When you can answer 80% of the typical interview questions, most ask interview questions, then it's time for you to switch and target Q2, like April to June, or maybe Q3, June to September, where these are hiring spikes starts happening in all the domains. And what kind of strategy you can use while building the resumes thing without burning the current jobs? That's more important. That is a top fear many of you might be having, that okay, what if my hiring manager, or what if my present manager or company gets to know, right? Maintain 2 versions, like current role and analog focused resume. So you can always add your present skills or the in analog skills as an added skills. Nobody questions you that if you learn something and you add in your resume though, that your added skills. Update the same skills in the LinkedIn also, that these are added skills along with the present skills in the industry. And keep current role active and visible until offer letter in hand. I'm not telling that you should neglect your current role. That's the bread and butter. I want you to focus on the current role. When once you finish whatever the current role you are doing, a current job you are doing, then you can spend 2 to 3 hours extra while attending the interviews to learn better in for the interviews. And the last and the important one, along with all these things, this imagination technique is very much important, that it helps you to believe in you that you can do it. Example, so the parallel path mindset, how much time duration it will take? Do you think it will take again 2 to 3 years? No, definitely not. Many of the people who have done it in 4 to 6 months, many of my trainees are like in worst case 9 months. If you're learning along with the job, along with all the different conditions of your family conditions, so it will take maybe 6 to 9 months transition plan. And it's not impossible, because you have done the same electronics, other people have done the same electronics, only you are trying to learn the new skills. Now you can learn better because you are already understand how industries work. Treat learning as a structured second job, same seriousness. If you're not able to switch in next 6 to 9 months, you should consider that you are not interested in this domain. So I want you to consider it very structured and serious format. Don't get overwhelmed. Track weekly milestones, circuit designed, not just like again theoretical things. One day you study, one day you did not study. That does not count. So how many circuits you designed? And third one important is like plan the offer acceptance movement from the day one. Like I want you to visualize like, okay, this is possible first because you have done the electronics, and this is for the electronic engineer, and this is possible. You can visualize whatever the company you want to go, whatever the offer you want to get, whatever the CTC you want, visual as if it is happening for you. So this visualization gives you the power to the imagination to believe that it is possible. The reason I'm telling you, when I spoke to many of the engineers, their biggest doubt was not technical. Their biggest doubt was, can I do it? Do you think it is possible for me? Yes, it is possible. If you make a structured roadmap, any of the 3 strategies you can use, make a structured roadmap, how you can switch from the present skill and how you can switch to most demanding skills in next 10 years. The best thing is like, if you don't have time to spend, if you want to leverage your money, if you want to leverage all the resources, you can also get into the top training institute who is ready to help you from wherever you are with the hand holding to where you want to be in the semiconductor industry. Those are the best thing if you can offer for the hands-on training, and you will save your time, you will save the long trial and error method what you are going to take in future, and it will cut short. And this person who is training, if this person is there already where you want to be, and you have to learn his blueprint or learn his formula, how you can reach from here to this point. So hope this helps you to transition the most demanded skills in next 10 years. And I want you to earn more with your potential and be AI resilient with getting into core hardware designs. And third one, if this is the time that never before, this much demand for the semiconductor engineers, this much demand for the analog IC designers. This is Mabin Adaf. See you in the next video with a more amazing topic.